Easier than when we did the surface area with this. Okay, so I just want to talk about this for a second. Hey, let's go. I'm just holding this under here for my homebound student for a second. Okay, well, we did this shape before, because this is the same page as before, except for its volume. When we did this shape before, and we were talking about surface area, if you imagine painting all of this, would you paint every surface that there was?
No.
No, what wouldn't you paint?
The bottom and the top. Bottom thing and the bottom of the top thing.
Yeah, I want to paint the bottom of the triangular prism, and I want to paint the top of the rectangular prism. So if I was doing surface area, I'd have to do all the surfaces but those. But volume is different. Volume is, I actually need to fill this entire shape up with air. So if I wanted to fill this entire shape up with air or with water, I'd have to fill the entire triangular prism up, and I'd have to fill the entire rectangular prism up. So I just find the volume of both shapes and add them up. I don't have to worry about any surfaces that aren't there. I worry about that with surface area because you don't paint all the surfaces in a shape like this. But if you're filling it all with water, you're filling it all with air, you'd fill the entire triangular prism and the entire rectangle. Does it kind of make sense to you? Okay, so that's what we're going to do. We're going to find the volume of our triangular prism that's on top. And then we're going to add it to the volume of the rectangular prism that makes up the bottom part of the shape. Okay. And then I'm just going to look at my formula chart for volume of the triangular prism and rectangular prism. Because they're both prisms, they'll both use the same formula, and our formula is capital BH. So both of these are capital BH, capital BH. Okay, let's start with the triangular prism.
Okay.
Capital B, what's it stand for again?
Base.
Area of the base. And what's the shape of the base for the triangular prism? The triangle. So I need to find the area of this triangle right here. I'm going to go ahead and I'm going to make it just a little bit bigger off to the side so I can work with it. Okay, this guy right here is 10, so that's this piece. That's a 10. I know that from here to here it's 12, so I know from here to here that that's a 12. My problem is I don't know the height of my triangle, so I need to figure out the height of my triangle. So now that I've done that, what is it from here to here? 6. And I need to find the height of my triangle. Do you know what it is? 8. This is a 6, 8, 10 triangle. But if I didn't know that, then I could go through Pythagorean theorem and figure it out. Okay, so now that I know that, how do I find area of a triangle? 1/2 base times height, or base times height divided by 2. So looking at our triangle, what is the base of the triangle? 12. And what did we just find the height to be? 8. Okay, and what do you get if you work just that out? What is it? Are you sure?
48.
Should be 48.
Oh, and I put in 6.
Mm-mm. Yeah, for me, like to do that in my head real easy, I'll just take the 12 divided by 2, which is 6, and 6 times 8 is 48. So the area of our triangle is 48, and that's the area of the base for our triangular prism. So I'm going to put a 48 in the capital B. And then how tall does this triangular prism stand? 25. Okay, go ahead and give me an answer for that. 48 times 25. 1,200. Okay, so now I need to work on the volume of the rectangular prism. And with the rectangular prism, it doesn't matter what you make the base. Any of those sides could be the base. I'm just going to make the bottom the base. So if I wanted to find the area of this base, I would take 12 times 25. And what does 12 times 25 give you? 300. So the area of the base is 300. And then how tall does it stand? 8. Beautiful. And what do you get if you work that part out?
2,400.
Very nice. And if you add them up?
Oh, you add them. 3,600.
Yes, 3,600 feet cubed. Because we are doing volume, and volume is always in cubic units. So this problem was much more difficult when it was surface area, because with surface area, you're painting all the surfaces that you see, and if this is your shape and you're painting all the surfaces, you don't see the bottom, you don't see the top. But if you're filling it up with air, you're filling it up with water or whatever, then you have the entire thing here you'd have to fill, and you have this entire thing here that you'd have to fill. So you just find the volume of both shapes, basically. Much easier. Okay, let's go ahead and go on down to number 3. So I'm just filling this whole thing up with something. What do you see here?
A cylinder and a rectangular.
The rectangular prism. And what is it about the cylinder?
It's half.
Yeah, it's only half. So we're going to find volume of a half cylinder, and I'm going to add it to the volume of the rectangular prism. Okay. Just a little bit ago, we looked at the rectangular prism. I know that that's capital BH. And then I just need to look at my cylinder formula.
Maybe a pi r h.
You already looked it up?
I believe it would be pi r.
What'd you say?
Pi r squared h divided by r.
Yes. So here's our cylinder, and the volume is capital BH, or we can use the pi r squared h, and then we would divide by 2 because it's half of the cylinder. So pi r squared h, and then divide by 2. Okay, so let's look at our cylinder and see if we know everything. Looking at the cylinder, do we know the radius?
Yeah.
What is it? 3. The radius is 3, so pi times 3 squared. And then how tall is the cylinder? 15. And then I'm going to divide by 2. Okay. Give me that answer, but keep it in terms of pi. Uh-huh. 67.5 pi. Very nice. Okay, and then the rectangular prism, like I said earlier, it doesn't matter what surface is the base. I'm just going to make the bottom the base. So the area of that base is 90, length times width, so 90. And the height? 4. And what'd you say? 360. Okay, go ahead and just add that in your calculator, putting pi in there. And
427.5.
what'd you say?
427.5. So pi, yeah.
Oh, I can't add these together and get a pi answer. The reason, if this 360 had a pi behind it, I could add the 360 and 67.5, but if this doesn't have a pi behind them, you can't actually add these. They're not like terms. So just put this whole stretch right here in your calculator, including the pi. Yeah. 572.1 inches cubed. Now, if I wanted to leave the answer exact, because this is rounding, if I wanted to leave the answer exact, it would have been this one right here, the 67.5 pi plus 360. That would be me leaving my answer in terms of pi, because I can't do anything else with that. But this is just a rough estimate here. Okay, what do you think of that so far? Seem easy peasy? All right. Okay, let's look at this guy. All right, so I'm filling the whole thing up with something. What do you guys see here?
A cube and a pyramid.
Okay, a cube and what kind of pyramid?
Square.
A square pyramid. And it doesn't really matter. So I'm going to find the volume of a pyramid. Doesn't matter what kind of pyramid it is, really. They all use the same formula. And I'm going to add it to the volume of a cube. And a cube is the same thing as a prism. Just all the sides are the same. Okay, so a pyramid's formula for volume, we have 1/3 capital BH. So 1/3 capital BH. And a cube is a rectangular prism. It just happens to have all sides the same length. And so that's just capital BH. Okay, let's start with our pyramid. I'm going to take 1/3 times the area of the base. So what would the area of the pyramid's base be? 144. Beautiful. And then I need to know the height of the pyramid. Do we see it in there? No, we do not. Now, the other day we had this problem and we did this. The other day when we were doing surface area, we had to know the slant height, this guy here. And I knew this one was a 10. And what did we say this one was?
6.
6. And what did we figure this out to be? 8. So the other day we used the 8 because we were doing surface area, and with surface area you have to know slant heights. Okay, so I need that 8 actually for today. So let me find a different color marker. What is this piece right here? 6. And I need to know the height, which is this guy right here. So what would I need to do?
Tag them in two.
That's exactly right. What would it look like? What squared plus what squared is what squared?
6 squared plus x squared equals 8 squared.
Beautiful. 6 squared plus x squared equals 8 squared. Okay, take a second, work that out, round to the nearest tenth, and I will draw a stick. Did I write something wrong?
Would it be 5-point tweet?
Oh, are we doing the diagram here?
Yeah. What'd you guys say? Oh. Did you wonder if it would be a 10?
Yeah.
Okay, the thing about the 6, 8, 10 triangle is the 10 has to be the hypotenuse. And in this problem, with this being my triangle here, my right angle's right here, and the 8's the hypotenuse. And so it's not a 6, 8, 10, because 10 is the longest side, and it'd have to be the hypotenuse. What? Yeah, I have it somewhere. No, I do have it, and I think I actually scanned it the other day. Oh, okay. What's the problem? Can I call you back? No, I'm teaching. Can I call you like in 10 minutes? Okay. Bye. Sorry. So sorry.
I like how you answered it. You're just like, what?
That's because I saw who was calling me. Friend that harasses me.
None of your concern.
Autumn, I drew you.
Oh, you got it.
What'd you get?
I got 5.3.
That is it. So we get x to be about 5.3, and that is the actual height. So that's going to go into my h. Okay. Let's just keep going. We don't need to work that out. When we look at the cube, area of the base of the cube, 144. Beautiful. And then how tall is it? 12. Okay, take a second and just put all that in.
Divided by 3. I got 830.4. Is that not right?
For a total answer?
Yes.
Did you divide the whole thing by 3?
Yes.
No. Only that thing right there will get divided by 3, not that part.
1982.4.
Yeah.
Christian, very nice. 1982.4. And that would be millimeters cubed. Boop, 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 boop. Are you liking this lesson?
Yes, it's so easy.
Do we need to do any more?
No.
Yeah?
No.
Well, no, I'm going to give you some to do on your own, but do you need me to do any more with you? No? You sure? Okay, so let's look. This is the same assignment as before. It just looks different. I'm not going to make you do them all. But definitely number 2, because he's pretty. And we should do number 4. And I think we should do number 5. And I think we should do number 6. That's it. 4 problems. 2, 4, 5, 6.
That's all.
Well, that's your homework, but look at the clock. You have more than 20 minutes. You have like 25 minutes. 25 minutes to do 4 problems. That's right. Get it done. Colton, I like that phrase. Good job. Is that a whistle? Have you seen